اوكي راح الانترنت. So I will repeat this step. G prime x equal px over x. So G prime x has the same sign as px since x is positive. From the above table, px positive if x greater than 1. So here, x, g prime x, gx, domain from 0 to plus infinity. The x greater than 1, px is positive, and g prime x is positive. And here it is negative, decreasing, increasing. G of 1 is equal to 1. Any questions? Please, any questions, ya shabab?
No.
شبكنا نعسانين اليوم. Part B, reduce the sign of gx. What's the sign of gx?
Positive.
Why positive? Yes, it is positive, but why? Deduce. How to deduce the sign of gx? From where we need to deduce the sign of gx? We have done the table of variations.
G prime x.
Since the minimum of gx, what's the minimum of g?
Positive.
How much is the minimum? 1. So minimum gx equals 1 greater than 0 implies that gx is greater than 0 for all x belongs to 0 plus infinity. Part 3. Consider the function f defined on 0 plus infinity by fx equals x plus 1 plus x plus ln x over x squared. And denote by C its representative curve in an orthonormal system with the unit equal to centimeters. Part A, calculate the limits of f over the boundaries of the domain. Deduce the equation of the asymptote. What are the boundaries of the domain?
0 and plus infinity.
What is the limit at 0? So limit as x tends to 0 plus of fx, we replace each x by 0, 0 plus 1, plus 0 plus ln 0 plus over 0 plus. Length 0 is minus infinity. Length 0 is minus infinity. We get 1 plus minus infinity over 0 plus. Length 0 is minus infinity over 0 plus equal minus infinity. Then x equal to 0 is a vertical asymptote. Then the line D, x equal to 0 is a vertical asymptote. The y-axis. Now limit al plus infinity. The second boundary is plus infinity. Limit as x tends to plus infinity. We replace each x by plus infinity. It becomes infinity plus 1. Here the numerator, infinity plus infinity, is infinity over infinity in determinate form. Infinity over infinity is indeterminate. We apply Hospital's rule to the fraction part, not to x plus 1, only to the ratio. So using Hospital's rule, so I have here to state, I use Hospital's rule or Haika's rule. Limit as x tends to plus infinity. Notice that x plus 1 remains x plus 1. Derivative of x is 1. Derivative of x is 1 over x over 2x. Replacing x by infinity, what do you get? We get infinity plus 1. This one becomes 0. 1 over infinity is 0. So 1 plus 0 over infinity, 1 over infinity is 0. We get plus infinity. Any questions? Part B. How to prove that the line delta of equation y equal x plus 1 is an oblique asymptote to C. How to prove oblique asymptote to C?
Normal fx minus y.
Limit, so limit as x tends to plus infinity لل fx minus y delta. نعمل limit as x tends to plus infinity لل fx minus y delta. بيطلع limit as x tends to plus infinity. fx minus y delta, we get x plus ln x over x squared. It will be infinity over infinity. Using Hospital's rule, equals limit as x tends to plus infinity. X is 1, derivative of x 1. Derivative of ln x is 1 over x over 2x. Derivative of x squared 2x. This one is 0. So 1 over infinity is 0. Then the line delta is an oblique asymptote to C. Since the limit as x tends to plus infinity is equals to 0.
تيست بالليميت دائما ناخد بلس انفينيتي مو x
حسب
tends to plus.
الدومين بالاكسبوننشال according to the domain. Here بالlogarithm here we have plus infinity.
Yes.
Part C. Consider the function hx equals x plus ln x. So we have the function p بعدين g بعدين f بعدين h. 4 functions. Part 1. Prove that the function h is strictly increasing over 0 plus infinity. How to prove that the function is strictly increasing?
نعمل derivative.
نعمل derivative. شو لازم يطلع الديريفاتيف؟ For the function to be increasing, the derivative should be positive. So this is hx equal x plus ln x. Domain is 0 plus infinity. Now h prime x, derivative للx is 1. Derivative للn x is 1 over x. Since x is positive, then h prime x is positive. So h is strictly increasing over the interval 0 plus infinity. H is strictly increasing over 0 plus infinity. Part 2. Deduce that delta intersects C at a unique point with abscissa alpha, alpha is between 0.56, 0.57, and alpha plus ln alpha equal to 0. Who can tell how to deduce that delta intersects C at a unique point with abscissa alpha? How to find the intersection between the curve and the line?
Y equals to y.
Y equals to y. So here, part 2, delta cut C means fx equals y delta. Fx is x plus 1 plus x plus ln x over x squared. Y delta is x plus 1. X plus 1 with x plus 1. We get x plus ln x over x squared equal to 0. It means that x plus ln x equal to 0 means hx equal to 0. How to prove the equation hx equal to 0 has only one root alpha? So h is continuous and strictly increasing. It is proved in the previous part that H is strictly increasing over 0.56, 0.57. H of 0.56 is minus 0.019, which is negative. H of 0.57 is 7.88 times 10 to the power minus 3, which is positive. One negative and the other is positive, so Hx equals 0 has 1 root alpha, belongs to 0.56, 0.57. H of alpha equal to 0 means alpha plus ln alpha equal to 0.
شنو نص
سلام حسين.
يلا بقيت مدام.
Yes, what's happening?
دقاسي كابانا هايدني نهر بيري هايدني تير شكي در
عم يلعب والله يلعب. فوكس.
يلعب
شباب ما عم تسمعوني؟
مضاف.
يا شباب. Are you listening?
No.
Okay, رح ارجع. I will enter Zoom once again.
شو؟
من جديد
ما بعرف ليش عم بيصير. What's happening?
هيدا من الواي فاي استاذ.
Okay. Are you listening?
Yes.
Yeah.
Yes.
Yes.
Yes. Now part 4 or part D. Study the relative position of C with respect to delta. How to study the position of C with respect to delta? We study the sign of fx minus y delta to study the position between the curve and the oblique asymptote or the line. Fx minus y delta equals x plus ln x over x squared equal hx over x squared. So fx minus y delta, we get x plus ln x over x squared equal hx over x squared. So hx equal to 0, it has one root at alpha. I put here the domain 0 plus infinity, fx minus y delta, and the position. This is alpha, negative, positive. We can take a value greater than alpha and we replace it here, like 1. We get positive here, negative here. Negative, معناتها C is below delta. Positive, C is above delta. 0 means C cuts delta at alpha, alpha plus 1. Alpha plus 1, we replace it in the equation of the line. Line delta was y equal x plus 1. Replacing x by alpha, we get y equal alpha plus 1. So position is determined by the sign of fx minus y delta. 4. Prove that f prime x